All right, this is 3.5. This lesson talks about scatter plots and lines of fit. So scatter plots are basically just a bunch of data and you plot them. It can be data about anything. On this example, we have temperatures of a certain place after sunset. And you can see after the sun sets, the temperature starts to drop. And I have my XY chart, my list of data that I have. And then I just plotted all of those points. And notice I have, this is temperature over on the side, temperature in Fahrenheit. And this is hours on this, the X line is about hours after sunset. So 1 hour afterwards, 2 hours afterwards, and so forth. And you can see the temperature keeps dropping afterwards. I also want you to notice this is a scatter plot. If I connected those dots, they don't make a straight line. That's why they're called scatter plots. They're kind of scattered all over the place. Sometimes they have a pattern, and that's what I want you to notice is sometimes scatter plots have a pattern. I want you to kind of notice the trend or the pattern, or another word in math we use is correlation. Correlation just means pattern. What is the pattern that's happening here? Well, you can see that the temperatures keep dropping after every hour. They keep dropping. And so that's what I want you to notice. They literally keep dropping, and they call that, this is a trend that's happening, or correlation. And so this would actually, notice, if I kind of drew a line, just a quick line, kind of going through the middle of those, just a quick line, notice that this guy, this line has a negative slope. It's going downhill. The temperatures are dropping. So this actually would be, this would be called a negative correlation. Or again, correlation means pattern. These numbers, these temperatures that we're talking about, this data has a pattern that keeps dropping hour after hour, so it has a negative correlation on this. Now, if we look at another city or another area, and we're talking about temperatures after sunrise, so we're talking about the temperatures rising up after the sun comes up, the temperatures start to rise up. And so something similar, I have some data, I plotted those points, and you can see if I kind of just draw a line, again, if I connected this does not make a straight line, but if you try to draw a line that goes through the majority of the points, one straight line, again, you don't sit here and try to connect them, you literally just make a straight line that would go through the majority of them. And again, so some of you might draw a line like that, okay? Or some of you might draw slightly down like this. You try to draw the best fit line that goes through them. You want to try to go through as many points as possible, and that goes through the middle of them. So you want to draw a line that maybe half of the dots, half of the points are above it, half of the points are below it, and then obviously you're trying to go through as many points as possible as well. So, this line that I have drawn here would be a, fairly decent best fit line. And that's what you really want is, the best fit line that you have some of the points that go through it. Notice I hit it right there. I hit that point right there. I also hit it right there. And it comes close to a couple other points. But I also want you to notice that it goes through, or there's about 3 points here below it. There's 3 points above it. And then there's some, right at the end, there's like 3 points really close to it. So I think I drew a good best fit line that goes through that thing. And again, that's what you're trying to do, is trying to get, notice a general overall pattern. And notice, this guy is going uphill. So this would have a positive correlation. Again, the word correlation means pattern. The trend means what is the pattern, the trend line that goes through the majority of that. And then notice it's a positive correlation. Well, let's look at another scenario where, again, I just took it like a school, the data from a school, again, since year 2011. And so the first year, this is talking about the first year since 2011. So that's actually talking about 2012. And then two years past it, 3 years past it, and so forth. So that's years since 2011. and this is the number of students enrolled. So you can see the number of students in my XY chart, and I just planted those or plotted those. And all I'm going to do is I want you to notice the pattern between them. Notice the pattern. If I draw a best fit line that goes through them, and again, you can use a ruler or just eyeball it if you have a good straight, if you have a steady hand. Again, you want to try to hit as many points as possible and trying to go through the majority of them. And so this may take a little bit of finagling just to make sure that you're trying to hit as many. Sometimes you can't go through every single point, or sometimes it's possible you might not be able to go through all of them or any of them. So I'm going to draw my best fit line about there. I think that's about kind of sort of in the middle of all that, and I do hit several of my points. Again, the best fit line, it doesn't mean it's the best fit line. It's a line that is very close estimate, okay? The very close estimate. So if yours was a slightly higher than that, then I understand that. That's as long as it's very close to it, and that's okay. I do have several. I have actually 5 points above it, and only really 1 point below it. So it really could have been a little higher than that. But what I was also shooting for is trying to hit as many points as possible, and then trying to make it as equally spread out as possible. But also notice what I have here. I have the overall correlation of this is positive. So this is a positive correlation. And one of the things that I want you to notice, one of the reasons why we do correlations, real companies do this, schools do this, companies do this, stock market does this, and because what they're trying to do is trying to predict. Notice this only goes up to 10 years. Well, what if I ask, like, what would be the population if this school continued to grow in the same pattern? What would be the year, or what would be the population of the school, the enrollment of the school in 15 years, or 20 years, or 25 years? And cities do this, schools do this, and they try to plan ahead. And if the school keeps growing, or if the city keeps growing, then what do we need to do? We need to build more roads. We need to get a better bus system. We need to, whatever it's talking about, that's the trend line or the correlation, the pattern, and we need to make a prediction. And so what if this continued on, 3 years later, 5 years later, where would it be? Well, one way to do this is to make an equation out of this. And that's one of the reasons why we want to look at this, is we want to make an equation out off of the line that we did. Well, if you remember how we made an equation, we first need to find the slope of this. And what we're going to do is choose any 2 points on that line. So the points that actually hit my line, I could choose this point, I could choose that point, or that point. So I'm going to choose any 2 of those points and then calculate the slope of that green line. So what I'm going to choose is any of those points that actually hit that line. And again, it doesn't make a really difference. You just find the slope of this. I'm going to choose literally the first one, and I'm going to choose the middle one. So I'm just going to choose those 2 points. So I'm going to choose this point and the middle one. So you can do this by rise over run, or you can do this using the formula y2 minus y1 over x2 minus x1. And if you do that, y2 minus y1, I'm going to get 310. Again, I'm using, the 2 that I have checked here. I'm using these 2 points. I'm going to get 310. And then x2 minus x1, I'm going to get 5. And then 310 divided by 5 is 62. So my slope is 62. Or, rise over run, it would be 62 over 1. And to write an equation of this, I'm going to use point slope form. And I'm going to go ahead and use my first point. I'm going to use this point right here. And so y minus 470. I'm using point slope form. Remember, point slope form is this. and my slope is 62, and then x minus 1. I could have used this point as well, but I used 1/470. I used the first point just because it was smaller numbers. Use the distributed property here. I get 62x minus 62. And I'm going to add 470 to both sides. And then once I get my answer, I'm going to notice it's 62x plus 408. Again, that's y equal to mx plus b. And you can kind of see that the y-intercept's there, 408. And then it's going up 62 over 1, up 62 over 1, up 62 over 1. And that's pretty much the line that I have graphed right there. And what this is good for is now I can make an XY chart. And this is where the calculator is going to come in very handy to be able to make the prediction. All right, so I grabbed my calculator and I punched in 62 plus 408. And then I want you to, if you go to the table, you can see something that it has all the data. And notice my XY chart that I have over here, this is the real data, the actual data of the school. And what you see on my calculator, again, because this formula is an estimate, because I drew my line in between them all, it's just an estimate of the data. So for instance, if you look at let's just look at the 10th year. The 10th year, according to my calculator, should be 1,028. And if you look on my actual chart, it's 1,020. So again, this is a best fit line. It's very close to the actual population. It's not exact, but it's very close to it. You draw the best fit line to be able to, to come very close to the data that's on there. And you can compare all of them, and they are very close to the numbers. Again, they're not exact, but they're very close. And what we're going to do is make a prediction now. So what if this graph continued to 12? If this continued 11 and then to 12 years past it, well, we could see what the population might be, and it's right here. It might be at 1,152 if the population continues to grow in the same way. And so I might say, in 15 years past it. So then the population would be 1,000. And again, if the school continues to grow that much, that's why it's good to predict that so that they might have to build another part of the building. They may have to hire more teachers. And so you have to look at the population to be able to see what that is and make prediction of where that is. Also, be careful of, since this is 2011, since it started in 2011, remember this is 2012, 2013, 2014, 2015. So when we talk about, year 15, that's 15 years past 2011. So that's actually talking about the year 2026. So just keep that in mind. So when I make a prediction about something, you pay attention to the key of the graph, and because that's years since 2011 to be able to do that. And that's scatter plots and best fit lines, and noticing if there's a positive correlation or a negative correlation.